basic logic gates. After Shannon applied the Boolean algebra in a telephone switching circuits, engineers realized that this Boolean algebra can also be applied to the electronic circuit of the computer system, that is CPU. So here we have got a logic gate. What do you mean by logic gate? Logic gate is an electronic circuit that is used to operate on one or more than one input to produce an output. It is called as logic gate. There are three basic logic gates. The first one is NOT gate, or we call it as inverter gate. Now the second one is OR gate, and the third one is AND gate. So now let us continue with the first one, that is NOT gate. NOT gate is nothing but it is a gate which is used to produce the output which is exactly opposite to that of the input. For example, if I take the variable x and x bar is the NOT gate, that is complementation or inverter of the x. Suppose I say the value of x is high, that is bit number 1, then the NOT gate gives me low. So here the output is exactly opposite to that of input. If the output input is low, then the output of the NOT gate is high. In a similar way, here we can write x bar. Here x is a logical variable which will receive either 0 or 1. If I NOT this, it will become 1. If I NOT 1, then it will become 0, right? So here symbolically we will be representing NOT gate as something like this. So if we input x value, we are going to get the complement of it. Yes, let us move on to the second gate, that is OR gate. Yes. So how to represent OR gate? OR gate means false, false is false, otherwise all the set of values of combinations of variables are true, right? Yes. So let us take two variable truth table for OR gate, and we know that this is the logical addition, right? So x, y, and here it can be written as x or y. Let us write the value of x and y. Here 0, 0, 0, 1, 1, 0, 1, 1, right? So we need to write this in order, because 0, 0 when we convert binary to decimal it will become 0, 0, 1 represent 1, 1, 0 when we convert binary to decimal it will become 2, 1, 1 represent 3. So we have to write it in a increasing order, right? So or means what? Or means false, false is false, otherwise it is true, correct? Yes. Now here we have got the truth table that consisting of only two variables. What if we have three variables? We are going to get 2 to the power 3, because we have got two binary number and three variables. So that gives me 2 to the power 3 is equal to 8. So 8 rows I am going to get. Here we got 4 because 2 to the power 2. So two binary numbers we have, and to the power 2 is two variables we have. So that's the reason 2 to the power 2 gives me 4. So that's the reason we have got 4 rows here. So let us draw the truth table that consisting of 3 variables. Now here we are going to write x or y or z. Let us write the input values of x, y, z. 0, 0, 0 for the first time. 0, 0, 1. Next 0, 1, 0. 0, 1, 1. Next 1, 0, 0, 1, 0, 1, 1, 1, 0, then 1, 1, 1. So here when we convert all these three values, so it will be 0. So 0, 0, 1 represent 1 in a decimal number system. 2, 3, 4, 5, 6 and 1, 1, 1 represent 7. We have written all of them in a increasing order. Now what is the result? false, false, false is false. Otherwise, it is true. So here you can see false, false, false is false. Otherwise, it is true. So here you can see in each of these rows we have got at least bit number 1. So hence all of them are set to true. Okay, fine. Next, how to represent OR gate? If we have two input OR gate, for example, I write x and y, we will be representing OR gate something like this. So here you can write OR and this is the output, that is x or y. If we have three variable input, then we write x, y, z, x, y, z, and we are going to draw OR gate something like this, or, and here the output is x or y or z. Yes, okay. Now let us continue with the next gate, that is AND gate. Here you will write the third one, it is AND gate. Here in an AND gate, true is true, otherwise it is false, right? Yes. So let us write two variable truth table, x, y, and AND gate always represent, it is a multiplication, logical multiplication. Hence we are going to write x dot y, which we have already studied in the previous video. Yes. So x, y values we are going to write 0, 0 for the first time, 0, 1, 1, 0, then 1, 1, right? So increasing order of 0, 1, 2, and 1 will represent 3, correct? Yes. Next, x and y is what? True is true, otherwise it is false. Let us continue with three variable truth table. Here we will write x, y, and z, and after that we will write x dot y dot z, that is x and y and z. Here we are going to write the values of the variable x, y, z as 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. Then we will write 1, 0, 0, 1, 0, 1, 1, 1, 0, then 1, 1, 1. Here you can see it is 0, 1, 2, 3, 4, 5, 6, and it represents 7 in an increasing order. Yes. So what is the result here? If the variable values are true, then it is true. So here three variables we have. If all the three variable values is true, then the result is true. Here true is true. Otherwise it is false. Correct? Yes. Next, how do you represent AND gate? So here, if it is two variable AND gate x and y, here we are going to represent AND gate something like this, and here we are going to write and the result of this gives me x dot y. Similarly, if we have three variable AND gate, then we are going to write x, y, z something like this. So it is AND gate. So here we write x, y, z. Now let us study basic postulates of Boolean algebra. Here postulates are nothing but these are the basic laws of Boolean algebra are called as postulates of Boolean algebra. So let us take the first postulate, that is, if x is not equal to 0, then x is equal to what? 1, correct? And if x is not equal to 1, then x is equal to 0, correct? And here we will write the second one, OR function. So that is OR gate function. So how do you write OR function? We know that it is a function or a relation that is used as a logical addition. We know that we can write 0 plus 0 is equal to 0. 0 plus 1 is equal to 1. 1 plus 0 is equal to 1. 1 plus 1 is equal to 1. So it is not 2 because 1 plus 1 is 2. 2 is crossing the limit of numbers in a binary number system, because in a binary number system we have got only two numbers, that is 0 and 1. Hence, any number greater than or equal to 1 represent it is always true. True can be represented in a binary notation as 1. Hence, 2 will be represented as 1. Yes. Let us write the logic gate for each of these expressions. So here the input value is what? 0, 0. Correct? We are using OR operation. How do you represent logical gate? So this is the logical gate, that is OR, and the output is what? 0, right? So here 0 or 1. 0 or 1 can be represented something like this. So here the result is what? Result is 1. Similarly, here you can see 1 or 0. 1 or 0 can be represented as or, and the result is what? 1. Similarly, 1 or 1. 1 or 1 represent output is 1, right? So next we'll move on to AND function or AND relation. So let us move to the third one. Here only I am going to write the third one. So that is AND function or AND relation. AND is nothing but it's a logical multiplication. Here we can write 0 dot 0, that is 0 into 0 is equal to 0. Next 0 into 1 is equal to 0. Then 1 into 0 is equal to 0, and 1 into 1 is equal to 1. Correct? So same can be represented in the form of logical gate as input is what? 0 and 0. Here we write 0 and is represented as something like this. Here it is and output is what? 0 only. Yes. Next expression gives us 0 and 1. 0 and 1. This gives me 0. Yes. Similarly, 1 and 0. 1 and 0 gives 0. Similarly, 1 and 1. Here I write 1 and 1. Here I write 1 and 1 gives me result as 1. Yes. Okay. The next and the last one is fourth one, that is not function or not relation, we can see. So here not relation gives us the exactly opposite result as that of the input. Yes. Here we are going to write 0. This gives us complementation will be 1. If 1's complement is there, then it returns 0. Here we will be able to draw the same expression as the logic gate for not can be represented something like this. If the input is 0, the output is 1. Correct? If the output is input is 1, then the output is 0. Yes. Okay. Now we will study principle of duality. Yes. What do you mean by principle of duality? Starting with one Boolean expression, we will be able to derive one more new Boolean expression is called as principle of duality. By changing, here we will write the definition. Principle of duality states that by using one Boolean expression or starting from one Boolean expression to derive another Boolean expression by number one, changing and to or. Yes. Next, second one is changing or to and operator. Yes. Next, the third one is changing 0 to 1 and 1 to 0. Yes. So try to understand, students, here. Principle of duality states that by starting with one Boolean expression, we are going to derive one more Boolean expression by changing and to or, changing or to and, changing 0 to 1 and 1 to 0. So let us take one small example so that we can understand the principle of duality. Let us take the OR function or OR relation. So OR relation can be written something like this. That is 0 or 0. This gives me 0 only, right? The next is 0 or 1. This gives me 1, right? Yes. Similarly, you write here 1 or 0. This gives me 1. 1 or 1 is equal to 1, right? So we will apply all these three steps to this particular relation. So here we have got the OR operation and here we have got 0, right? So what we need to do, we need to change 0 to 1, 1 to 0, right? So 0 is there, we need to change it to 1. Here we have got OR operation. What is the second step? OR to AND. We have to change OR to AND. OR will get changed to AND. AND means what? It is dot multiplication, logical multiplication. So 0 will become 1 is equal to this 0 will become 1. Correct? Yes. What we got here? True and true is true. We have derived AND relation from the OR relation. It applies principle of duality. So we will go for the next step. That is 0 will become 1. This OR operation will become AND operation. This 1 will become 0 and equal to this 1 will become 0. Yes. Next 1 will become 0 and OR 1 will become and this 1 will 0 will become 1 and the result is 0. Yes. 1 will become 0. So this 1 will become 0. OR will become AND, this 1 will become 0 and equal to 1 will become 0. You can see that we have derived AND relation from the OR relation. That's all in this video. Thank you very much for watching this video. We will see you in the next video.